In this application, we are going to find how many quarts of 6% butterfat milk and 1% butterfat milk should be mixed to yield 50 quarts of 5% butterfat milk. So what we notice right away is we have some numbers here, some with percentages. So these three numbers are all percent, but notice this number of 50 tells us number of quarts. So this is a clue as to what the two different categories should be when we set up a table of information. One of those will be number of quarts, and the other will deal with percent of the mix. So let's set up our table. We have a 6% butterfat mixing with a 1% butterfat. So I'm just going to write 6% and 1%. Our last column typically is some kind of a total. Notice that it does not reveal how many quarts of either of these percents of butterfat milk are being mixed. It simply says that we're having a yield of 50 quarts. That is the total. So I'll just use X and Y, making a total of 50 quarts. So when I'm mixing, that means I'm adding to make a total of 50. The first variable I've written to go along with 6%. 6% as a decimal is 0.06 multiplied by the number of quarts. That will be mixed or added to 1%. Be careful, it's 0.01 multiplied by the number of quarts. Since we don't know it, we're using Y. That will equal the total quarts. Now, this total is made up of two different things. One part is the quarts, which is 50. The other is the percentage that we are trying to create, and that's 5%. So we must multiply 50 quarts by the 5%, or 0.05. From this, we get our system of equations. X plus Y equals 50, and 0.06x plus 0.01y equals the product of 50 times 0.05, which is 2.5. Now, it looks like substitution would be a quick method, so I'm going to rewrite that first equation in terms of y. So that means I'm subtracting x from each side of that equation. Negative x plus 50 will be on the right. So I now have a substitution. Instead of y, I'm going to substitute negative x plus 50 into that second equation. With that substitution, 0.06x plus 0.01 times the new value of y, that's our negative x plus 50, equals 2.5. Remember, 2.5 came from multiplying 50 quarts times the 5% mixture. Now you'll notice we only have one variable in the equation, so we should be able to solve for x. We'll be distributing the 0.01 to each term in the quantity. We start with 0.06x, and then we'll have subtraction of 0.01x, and when we multiply 0.01 times 50, and when we multiply 0.01 times 50, that will give us positive 0.5. All that now equals 2.5. Notice we have some like terms to collect on the left, and we'll be subtracting 0.5 from each side of the equation to collect our like terms. 0.06x minus 0.01x leaves us 0.05x, and 2.5 minus 0.5 gives us 2. Notice that 0.05 is connected to x with multiplication, so we'll have to divide both sides of the equation by 0.05. That leaves x equals 2 divided by 0.05, which is 40. Now going back to the table, we can figure out what x represents. X is the number of quarts at the 6% solution. So it's 40 quarts at 6%. We still need to find the value of y. So we'll go back to our first equation. X plus y equals a total of 50 quarts. X is worth 40 quarts. So x will be replaced, or substitute 40 for x, plus y equals 50. Subtracting 40 from each side of this equation, y equals 10 quarts, and y is at the 1% solution. So you might see how useful it is to have that table to remind you of what each variable is representing. X represents the 6% solution, which happens to be the 6% butterfat milk, and y represents the 1% butterfat milk. So if we mix 40 quarts at 6% with 10 quarts of the 1% butterfat, that will yield our 50 quarts of 5% butterfat milk.